Alright, so welcome again everyone to this video lesson, and in this video lesson, this is the continuation, or this is the part 2 of the video lesson that we have earlier, which is called the balancing chemical equation. So since we are talking about chemical reaction in the first part of this video, so why not continue it to the types of chemical reaction and some sample problems regarding these types of chemical reaction. Now, whenever you predict a type of chemical reaction, so whenever you predict a type of chemical reaction or the product in your chemical reaction, okay, you should always balance it. That's the reason why we have the part 1 that is for balancing, and this part is for the types of chemical reaction. Now, in this particular lesson or video lesson that we will have today, alright, in this video, you will learn how to predict, okay, you will learn what are the different types of chemical reaction, and you will learn how to predict the product of each type of chemical reaction. Alright, so with that, we will not waste time here, and we'll go now to the main presentation. Alright, so we are here now on the presentation. So what are the types of chemical reaction? Alright, so there are 5 types of chemical reaction. One of them is one of them is synthesis, alright? Then one of them is decomposition reaction. The other one is single displacement. In other books, they use replacement. It's the same thing. Single replacement reaction or single displacement. Then followed by double displacement reaction. And number 5, combustion reactions. Alright, so these are the 5 types of reaction that we will try to discover. One of them, alright? And what is their general form? So that if you have a problem that deals with types of chemical reaction, you can easily distinguish what type of chemical reaction there is, or the problem or the chemical reaction is all about. Alright, so okay, this is what we will going to do on this video. We will need to identify each type of reaction that you have right here, and some examples that will let you appreciate each of the types that you have right there. Okay, let's start with the first type, which is called the synthesis. Alright, so what do we mean by synthesis reaction? So from the word itself, synthesis means combine. Alright, it means combine. So we have here the example of a synthesis reaction. So we have here a carbon that is combined with oxygen. So carbon that is combined with oxygen, and predict what is the product. Okay, you can pause the video and think of the product of these 2 reactants that we have right here. Alright, so the product is carbon dioxide. Alright, so the product is carbon dioxide. So it has a general form of AB, or A plus B equals AB. Alright, so this is the general form for synthesis reaction. Example that we have right here is carbon plus oxygen equals or yields to carbon dioxide. There you go. Other example of synthesis reaction is potassium and chlorine. Alright, so potassium reacts with chlorine gas, therefore it yields potassium chloride. Alright, so KCl. Now, as all things should be, or as all chemical reaction should be, it should be balanced. Okay, next one. Okay, let's try some sample problems, some mini sample problems that we have right here. Alright, so now what will be the product when these 2 reacts? Alright, what will be the product? So you can pause the video to have time. Okay? Okay, so the products are, we have NaCl. Now, this is not balanced. Alright, so this is not balanced. So we have 2 here, and we put here 2. Then that's it. That is the balanced form. Or sorry, I forgot to put here 2. Alright, so this is now the balanced formula for NaCl. There you have it. That is a synthesis reaction. How about this one? Magnesium plus fluorine gas. Alright, so let's take a look. So magnesium belongs to group number 2. Alright, so it belongs to group number 2. So therefore, it has Mg plus 2. Alright, then your fluorine belongs to group 7. So that will be negative 1. So there you crisscross. Just go it right here, then go right there. So we have Mg. Alright. F2. Alright, so there you have it. So is it balanced? Okay, so 1 here, 1 over there, 2 atoms here, 2 atoms over there. So therefore, that is balanced. Okay. Alright, how about this one? Aluminum and fluorine. Alright, so let's analyze this one. Aluminum is located on group number 3. Therefore, it has a charge of plus 3. Then fluorine is somehow negative 1. Alright, because it belongs to group 7. So just crisscross this. And there you have it. So we have aluminum. Alright, fluoride. There you go. Okay, so we have AlF3. So is it balanced? Alright, so is it balanced? So let's see. Two atoms here, 3 atoms there, 1 atom of aluminum and 1 atom. So balanced. The aluminum is balanced while the fluorine is not. So we will put here. Alright, let's think of a multiple of. Okay, let's think of a multiple of 2 that will end up the same answer on the other side. Alright, so let's use 3. Okay, let's use 3. 3 times 2, 6. So, let's use 2 here. 2 times 3, that is 6. So, aluminum, we will put another 2 here. So, that is the balanced form of aluminum fluoride reaction. Alright, so next one. There you have it. Yeah. Okay. Alright, so that is synthesis. Now, let's go to the second type of chemical reaction. That is decomposition. From the word itself, decompose. Coming from the word decompose, which means to separate. Alright, so to separate. So, in this chemical reaction, a product, alright, a compound will, one compound will try to separate using decomposition reaction, and it will separate to its constituent form. Alright, to its constituent form. Okay, so one example here is the NaCl. Now, earlier we combined it by synthesis, but we can also separate them using decomposition reaction. So, if you have NaCl, then what are its constituent? Obviously, we have sodium and chlorine. So, there you go. Okay, so don't forget to balance this one. Okay, so we have here the general equation for this decomposition reaction. We have AB. Okay, AB, decompose. Alright, so this one means decompose, not yields. Not yields. AB decompose to become A plus B. Alright, so that's the meaning of that. Okay, so what are other decomposition reaction? Okay, so what we have right here is mercury 2 oxide. Alright, so mercury 2 oxide, when you decompose mercury 2 oxide, you liberate oxygen and mercury metal. Now, this is one way of obtaining, alright, obtaining mercury using the mercury 2 oxide. Alright, so decomposition reaction, okay, with the action of heat. Alright, with the action of heat, you will be able to separate mercury from its mercury oxide. Okay. Next, the third type of chemical reaction is called the single displacement reaction. So what do we have right here? Okay, so in a single displacement reaction, like the one that you have, zinc plus copper chloride, alright, so what will be its product? Okay, so its product will be zinc chloride and copper. So what did you notice? So you notice that the zinc, alright, the zinc replaces the copper in your copper chloride. So what happens is it becomes zinc chloride and your copper is left alone. Okay? So there are conditions for this one to happen. So I will show you later the conditions for this to happen. Okay, so the general equation for the single displacement is A, B plus C. then we have AC, then B respectively. Okay, so the B is being replaced by letter C, then therefore you have now your AC plus B. Okay, so this is the single displacement or single replacement reaction. All right, so let's take a look. Okay, now I have right here reaction of water and lithium. Alright, reaction of water and lithium. So what is its product? Okay, so the lithium, alright, the lithium will replace the hydrogen in your water, then therefore it will form your lithium hydroxide. Okay, so it will form your lithium hydroxide and leaving alone your hydrogen in the process. So now in this example, this is one way of liberating hydrogen on your lithium. Liberating hydrogen from lithium and water. All right, so this is a very familiar example of single replacement reaction. All right, now just like what I've said, there is a condition about this. Alright, there is a condition about this. Now, we called it the activity series. Now, is it possible for a chemical or is it possible for a single replacement reaction not to happen? Alright, so you can put the answer in the comment section of the video. Alright, so the answer is yes, that is possible. If the one that will replace, the one that will replace the other element is at the bottom of this activity series. For example, you have here PB, alright, so PB plus zinc chloride. There you go. Okay, now, will there be a reaction on it? Okay, so let's take a look. Now, PB or the lead is below zinc. So therefore, if lead will try to replace zinc in your reaction, it will never happen because that is below. Alright? So the activity or the reactivity of PB is less than your so the lead is less reactive than your zinc. So therefore there will be no reaction that will happen. Okay? So there will be no reaction. So in short, anything that is on the top, alright? Anything that is on the top of the other element that is more reactive than the other element at the bottom. Same thing with this one. So fluorine is more reactive than chlorine, chlorine is more reactive than bromine, and bromine is more reactive than iodine. So basically that's how it works. Okay, so possibly a single replacement reaction cannot happen if the other element is less reactive and going to replace the more reactive element. Okay, so that is the activity series. So please watch out for this one, guys. Alright, next one. Just like what we have right here. Is this possible? Okay, let's take a look. Okay, now iron is located below. Alright, and copper is iron is located above your copper. Alright, so meaning to say that iron is more reactive than copper. Okay, so this is less reactive. So what happens is the copper can be replaced by iron in that reaction. So therefore, in this meme, it was kicked out of the car. Alright, something like that. Okay, so that is the activity series and it has something to do with single replacement reaction. Alright, so next one. Alright, write and balance the following single replacement reaction equation. Alright, so let's get right into it. Okay, so I have right here a chemical reaction of zinc plus hydrochloric acid. Okay, and it yields with zinc chloride and hydrogen. Alright, is it balanced? Okay, so as you can see, it is not balanced. So what we will going to do is we use the method that we learned on the previous video. So we have the metal first, followed by a non-metal, then followed by the hydrogen and oxygen. Alright, so the otherwise also, there you have it. Alright, so let's count the number of atoms. So in this case, we have 1. In this case, we have 1 as well. Then we have 1. Then we have 1 over here. Now, do you have 2 because of this? And we have 2 because of that. Alright, 2. Now, let's balance this one. Let's start first with the metal. So the zinc has no problem. Let's take a look at the chlorine. Alright, so since it has 2 here, so it has 2 here, so we put 2 over there. Okay? So we put 2 over there. So it will affect the number of chlorine, so it will become 2. So it also affects the hydrogen, so it will become 2. So therefore, balance, balance, and also balance. There you have it. Okay, next one. Alright, so hey, can we erase this one? Alright, so we can erase. Alright, so we can erase this. Alright, so let's erase. Okay, there you go. Okay, so let's take a look at this chemical equation below. So, what we have right here? Okay, so we have NaCl, alright, reacts with fluorine, right, and it produces sodium fluoride and chlorine respectively. Alright, so is this balanced? So let's take a look. So obviously it's not balanced. By looking at the chlorine, alright, so it tells you that it is not balanced. So let's balance it one more time. So we prioritize all the metals, okay, followed by the non-metal. Then there's no hydrogen here. Therefore, the final non-metal is the fluorine. Alright, so next one, we have sodium. We have chlorine, then fluorine, respectively. So, it has 1. It has 1 here, then it has 2. Next one, we have 1 here. Then we have 2 there. 2 atoms, and we have 1 over here. So, there you go. Alright, so how do we balance this one? So, there's no problem with sodium. So, we leave that one. We will ignore that one. So, let's take a look at chlorine. Since we have 2 here, so we will put 2 here on the NaCl. So, it will affect the number of sodium and chlorine atoms. So, we have 2 over here. Then we have 2 over there. Okay, next one. So, that makes it 2. There you go. And the chlorine is now balanced. Now, since you put a coefficient here, it will not balance the other one. Alright, the other sodium on the product side. So, what will happen here? So, if you have 2 here, you should put all 2 there as well. Alright? So, 2. So, we'll make it balance. Now, how about the fluorine? So, since you put a 2 coefficient there, it will affect the number of chlorine. So, 2 over there. So, there you have it. Okay? So, it is completely balanced. Okay, so, next one. Let's erase. Okay, let's punch the next. Okay. Alright, so the good thing here is the Microsoft has an erase function. So that's one good thing about this Microsoft. Okay, so let's okay, so this time let's predict what is the product. Okay, let's take a look at the reactivity series. Alright, let's take a look at the reactivity series if this is possible. Alright, so the aluminum will replace copper. Okay, so let's see. Okay, so where's the aluminum? There you have it. Okay, so this is more reactive than copper. Alright, so more reactive than copper, then therefore that is possible. Okay, so this chemical reaction is possible. So let's replace it. Okay, so aluminum has +3. Okay, because that is located on group number 3. Alright, group number 3. Okay, next one, the copper, alright, is -1. Or sorry, rather +1 because that is a metal. Now, the nitrate, the NO3 that you have right here. Okay, so the one that you use here is 2. Okay, this is a copper 2 rather than copper 1. Okay, so the nitrate has -1. Okay, negative 1 charge. Alright, so since copper will be replaced by aluminum, so it will be a crisscross between this one and this one. So the formation will be, alright, so the formation will be Al. There you go. Okay, Al, then parenthesis NO3, 3. So that is aluminum nitrate. Alright, so that is aluminum nitrate plus copper. There you go. Alright, so our problem now is how to balance this one. Okay, let's balance this. So let's write it down once more. Okay, so let's write all the metals. So aluminum, copper, then followed by non-metals, nitrogen, then oxygen. Then we'll use the same thing on the other side. So CuNO. Alright, so how many aluminum? So we have 1. Alright, so how many copper? We also have 1 on this side. Okay, next one. How about nitrogen? 1 times 2, 2. Alright, so 3 times 2, 6. Okay, there you go. Next one. Okay, so aluminum here is also 1. Then the copper is also 1 there. Then the nitrogen is 3 times 1, that is 3. And we have 3 times 3, this one. 3 times 3, that is 9. Alright, so there is your tabulation. Now, how do we balance this one? The aluminum doesn't have any problem at all because that is balanced for now. The copper also is also balanced. Alright, now our problem will be... Alright, so our problem will be the copper itself. Alright? Sorry, the nitrogen itself. Okay, now, if it has 2 here, alright, so let's think of a multiple, alright? Let's think of a multiple of 2 that will end up the same answer with the other side. Alright, so probably we can put here 3. Okay, let's see. Okay, let's see if 3 is possible. 2 times 3, that is 6. Alright, 2 times 3, that is 6. Now, and on the other one, so 3 times 2, that is 6, times 3. Alright, because of this 3, that is 18. Okay, let's take a look if that will not be affected here. So it will be affected because this is not anymore balanced. Now, to make it balanced, let's put something 2 here to have the same answer as the other side. So let's put here 2. 3 times 2, that is 6. Then 9 times 2 is 18. So we have balanced N and O. Now, our problem now is your copper and aluminum. Now, the aluminum has been added by 2. So we add 2 here, then 2 times 1, that is 2. Then on the other side also is 2 times 1, that is 2. Next, the copper has been added by, there are 3 moles of copper here. So we will add another 3 over there. So we have 3, then 3, then 3 times 1, that is 3. So we are now balanced as all things should be. Okay? That is for single replacement reaction. Okay? There you go. Okay, so we are correct. Okay, next, let's go to number 4, which is called the double displacement or double replacement. Now, in double displacement reaction, it includes the following. Alright, it includes the following. We have the neutralization. Alright, neutralization reaction. That is also double displacement. Alright, so another one is acid-metal reaction. Okay, acid and metal carbonate reaction. Okay, so these two, alright, so these two that we have right here are part of your double displacement reaction. So, okay, now let's have one example here. Magnesium oxide reacts with calcium sulfide. Alright, magnesium oxide reacts with calcium sulfide. So, what will happen here? Okay, now, if you have an idea what will happen here, just write it down in the comment section of this video. So, I think we have the same idea. So, it will crisscross, alright? It will exchange, alright? It will exchange its metal, alright? It will exchange its metal to its anion. Alright, so let's see. Alright, so just what we have predicted, it looks like this. Okay, so the general equation for this one is AB plus CD. There you go. So the metal, which is A and C, A and C, okay, has been exchanged, alright, in its compound. So it will have A. Alright, so A over here and C over there, then their B are now exchanged. Alright, so okay, so this is how double displacement form works. Okay, so let's take a look at what other examples do we have right here. Okay, now if you remember in algebra, we have this FOIL method, right? So we have this FOIL method. For example, 2 times x minus 1, or something like x minus 1 squared. Okay, so what does it mean? X minus 1 times x minus 1. So what is the FOIL method? So you multiply it right here, like so. Then next one. Alright. Okay, so outside first. Okay. Outside first, then inside. Alright. So now, think about the double displacement as the one that we have right here, the algebra. Okay? Think about it. Okay, it does the same thing. Okay? So, the NG can go here and the NA can go there. So, they can transpose. Alright? They can transpose and it looks like this. Alright, so the potassium can also replace the barium there, and the barium can also replace the potassium on that side. Alright, that is why it looks like this. Alright, so the good thing here, it is balanced. Okay, so that is the double displacement or double replacement reaction. Okay, so you know already why is it double? Because you have two switches. Alright, you have two switches that happen in your chemical reaction. So there are two switching, okay, processes. Alright, so there you have it. Okay, let's take a look at this sample problem that we have right here. Predict the product and balance the product. Okay, so let's take a look. Okay, so we have here the HCl. Alright, HCl, then AgNO3. So let's rewrite this one. Let's rewrite this one on our whiteboard so that we have more space. Yeah. Okay, so that is okay, so we have HCl plus Ag or silver nitrate. There you go. Okay. So what do we have right here? Okay, so we will predict what is the product of this and balance. Okay, now the hydrogen will replace the silver, and silver will replace the hydrogen on the other side. So therefore, we have Ag. Okay, so since silver is positive 1, silver is positive 1 and chlorine is negative 1, so there will be no problem on that. Okay, so let me double check first. I think I am incorrect on that. What is the charge of silver? Okay, so according to the periodic table, its charge should be alright, so +1. Alright, so +1. Okay, so let me double check it on the okay. Okay, charge of silver. Okay, so 2 plus. Okay, so since this is 2 plus, so we have 2 over here. Okay, so negative 1 goes there and positive 2 goes there. So we have silver chloride. Alright, next one. How about the hydrogen over here? So nitrate has negative 1 and hydrogen has positive 1. So that will be, okay, so we do not write 1 anymore. We do not put parentheses just for the 1. Okay, so we have it, this formula. So this is now your predicted products. Now, next one is balancing. Okay, so let's write it down one more time. So let's prioritize first the metals. Right? So let's prioritize the metals. So we have Ag, then followed by non-metals. So we have Cl and OH. Okay, so like so, Ag, Cl, and OH. There you have it. Okay. Alright, so let's see. Okay, how many Ag or how many silver do you have right here? So we have 1. Okay, so how many Cl? So we have 1 as well. Then we have nitrogen, so we have 1. Oxygen also, we have 1. Sorry, rather 3. Okay, let's erase. Okay, so we have 3. Okay, so I have a doubt on this. Okay, so I am wrong. Okay, so the silver that they use here is, okay, so the silver that they use here is 1 because of this, right? Because of this formula that you have right here. So there's no parenthesis here. If this is 2, all right, so if this is 2, there should be a parenthesis. All right? So there should be a parenthesis here. So on this one. So if this is 2, okay, if this is 2, there should be a parenthesis. So there's none. So it's supposed to be 1. Okay, so okay, that's 3. Then hydrogen we have 1. Okay, let's go to the other side. Ag is 1 as well. Cl is 1. N is 1. O is 3. Then H is 1. Okay, so in this case we have a balanced equation. All right, so there's no problem with the equation. It's already balanced. Okay, so next one. Okay, next sample problem. Okay, next sample problem that we have is CaCl2 or the calcium chloride. Alright, reacts with sodium phosphate. Okay, so let's answer this one on the whiteboard. Okay, CaCl2. Okay, so we have a new... Okay, let's switch it to a new whiteboard once more. Alright, so... Okay, so CaCl2 plus... Okay, and sodium phosphate. Alright, so sodium phosphate, Na3PO4. Alright, so predict the product. So this is a double displacement. So calcium. Alright, so calcium will replace sodium. So the product will be... Okay, so we have calcium is... calcium belongs to group number 2. And chlorine is negative 1. So this is plus 2. Minus 1. Alright, so this is plus 1 and plus or minus 3 rather. Okay, so we will write now. So we have calcium. Alright, 3 PO4 parenthesis 2. Okay, there you have it. Next one. The other product, we have sodium. Sodium will go here, so there's no problem there. So NaCl. So both of them are plus, both of them are 1. Okay, so let's take a look at this sample problem. Okay, let's balance this. Okay, let's put all the metals. So Na, calcium, Cl, phosphorus, and oxygen. Alright, so like so, Na, Ca, chlorine, phosphorus, and oxygen. Alright, so let's have first the number of sodium. So we have 3 on this side. So we have 1 coming here. And we have chlorine coming there. Coming here. It is 2. The phosphate is just 1. And the oxygen is 4. There you have it. Next one. On this side, we have Na1. Calcium is 3. Then chlorine is 1. Then we have phosphorus. We have 2 times 1. 2 times 1, that is 2. And oxygen, 4 times 2, that is 8. There you go. Alright, so what are we going to do here? Okay, so since... Alright, so I will use green. So since you have 3 here, so let's put some 3 there. Alright, so... Okay, so that makes your sodium balanced. Alright? That makes your sodium balanced. Okay, so let's see if that will affect the chlorine. So the chlorine will become 3. Alright, so the chlorine will become 3. So what will happen? Okay, so what will happen? It's still not balanced on the other side because we have 2 here and we have 3 over there. So it is not possible. So let's remove this one. Okay, so I already... Okay, so let's rewrite it one more time. So this is 1 and this is 3. Okay, so what are we going to do here? Okay, how to balance this one? Okay, so let's think of a number. Let's think of a number that can be multiplied by 2 and 3 that has the same number. Alright, so probably we can put here 6. Alright, we can put here 6. So 6 times 1, that is 6. So we have 6 here. And on the other side, so we have 3 here. So we can put here 2. So we have 2. That will be 6. Okay, so next one. Since we have the coefficient here, it will change the 6 to become 6. Alright, so 1 times 6, that is 6. And since it is not balanced here, alright, so since it is not balanced, so the 3 here is being erased. Okay, so since we have 3 here, so we can put here the 3. Okay, so 3 times 1, that is 3. Then 3 times 2 now is 6. Alright, so 6. We have 3 over here. So 6, balance. Calcium is 3. Alright, so 3 over here, it is balanced as well. And chlorine is also 6, balanced as well. Now, let's take a look at the phosphate. Now, since you put 2 here, it will affect the number of phosphate. So we have 2. Okay, times 2, so that will be 2. Then oxygen, 4 times 2, that is 8. Okay, so fortunately enough, it is balanced on the other side. Alright, so this is the final balance form of sample problem number 2. Alright, so let's go back to our problem. So let's have the lead, PbNO3. Alright, so PbNO3, that is lead nitrate, then followed by barium chloride. Okay, so let's solve. Okay, let's solve for this one. Okay, so PbNO3. So let's write it here before we start. Okay, so PbNO3 2. Okay, plus barium chloride. Okay, now it is easy to predict the product. Okay, so whatever charge they use, it is seen on the reactants. Alright, whatever charge the reactants use will also be seen on the product. So, which means that the lead that they use here is plus 2. Okay, so the lead that they use here is plus 2. So, it will likely to form, right, so it will likely to form on the other side, PbCl2. Okay, PbCl2. This is the plus 2 that we are talking about earlier. Plus, okay, so barium that they use here is plus 2 because of Cl2 that you have right here. We all know that Cl is negative 1. Alright, so what happens here is you just use it. Ba has, or barium has plus 2. So therefore, we have barium NO3 2. Okay, so since NO3 is negative 1. Okay, so we are now good and ready to go. Let's balance this. Okay, so let's write down all the metals. So Pb, Ba, Cl, N, and O. Alright, so on the other side, Pb, Ba, Cl, and O. Okay, so there you have it. Okay, so what do you have on the first side? So we have, so this one will not, okay, this one will not affect the number of this, so still 1. So Ba is 1, Cl is 2. Next, N is 2 times 1, that is 2. Alright, next, oxygen is 3 times 2, that is 6. There you go. Next one, Pb, 1, Cl, 2, barium is 1, and nitrogen is 2, then oxygen is 6. Now, our problem is none. It is already balanced. Okay? So, it is already balanced, so we are good and ready to go. Okay? Next, we go to the next sample problem. Okay, what's next? Alright, so we have FeCl3. Alright, so we have FeCl3 top and NaOH. Right, so FeCl3 then NaOH. Where's the cursor? There you go, and okay. So let's write it down there. Okay, FeCl3 and NaOH, or sodium hydroxide. Now, what is the expected product here? Okay, so what is the expected product? So we have, okay, so the Fe, or the iron that they use here, is 3. So it is plus 3. Okay, so chlorine is negative 1. So we can have iron hydroxide. Okay, so you have your parentheses, then 3 over there. Plus, alright, so the sodium here is plus 1. So reacts with that. That is sodium chloride. Alright, so what do we have in this chemical equation? Okay, so is it balanced? Na there, Cl. Okay, so the Cl is not balanced, so we will try to balance it. Alright, so let's put some metals here. So we have Fe, Na, Cl, O, and H. Alright, so we have Fe, right, Na, Cl, O, H. Alright, so how many Fe? 1. Na also 1. Cl 3. O is 1. H is 1. Alright, so Fe 1, not 3. Alright, so do not put there 3. Next one, 1. Next, Cl is also 1. Then O, 3 times 1, 3. And H is 3 times 1, that is 3. Alright, so there's a problem here. Okay, Cl, O, and H are not balanced. Alright, they are not balanced. So, what are we going to do here? Okay, so we'll balance the metal. So as long that you have your guidelines, there will be no problem in this. Alright, so we'll balance the metals. So we have, okay, so the metals are, there's no problem with the metals. Now, the chlorine has the problem. Okay, now if we put 3 here, okay, it will balance the chlorine. So let's take a look. So 3. Okay, so that makes it chlorine, that is 3. So 3. Then your Na now will be changed to 3. So we will put 3 over here. Then 3. Then 3 over there. Okay, now since you put there 3, it will affect the oxygen and hydrogen. So we have 3. Then we have 3. So 3 hydrogen. Alright, so I think we are done. Okay, so 1, balance, iron. Sodium has 3 atoms, balance. Next one, chlorine has 3, also balanced. Next, oxygen is 3. Then hydrogen is also 3. Then therefore, this is balanced. Alright, as all things should be. Alright, so that is your double replacement reaction. Alright, so let's go now to the last type of reaction, which is called the combustion reaction. Now, what is this combustion reaction all about? From the word from the word itself, which is called combust, means burn. All right. Now, the combustion reaction involves hydrogen or hydrocarbon that reacts with oxygen gas in the atmosphere. Then, when it does, it burns. Alright? It burns or it combusts. Alright? This is the principle that is used by internal combustion engine. Alright? If you are burning wood, alright? If you are burning an alcohol, alright? So, if you are burning gasoline or diesel fuel, something like that, that is a combustion reaction. Now, in order to burn something, you need three things, alright? Number one is the fuel, which is the hydrocarbon, alright? Sometimes, we have right there like methane, alright? We have ethane, okay? Butane, something like that. Okay, next. Now, in order to burn that hydrocarbon, you need an oxygen. Okay, you need an oxygen. That's number two. That is very important. You cannot burn things without oxygen. Okay, and number three, okay, you need a spark, alright? A little amount of electricity to make the reaction possible. Alright? To make the reaction possible. So, okay, with those three in place, you can now have combustion reaction. Now, the general equation for combustion is this one. So, this is a hydrocarbon. Okay? It can be an alcohol in some cases. It can be an alcohol, but you can change this fuel. You can change the fuel, but not the other components. Because in a combustion reaction, there must be an oxygen, and there must be a product called carbon dioxide. Alright? You cannot have combustion reaction without the product of carbon dioxide and water. Okay? Including respiration. Guys, including respiration that we have. Okay? It is also a combustion reaction. Because we exhale carbon dioxide with water and we take in oxygen to burn the glucose coming from the food that we eat. Alright, so, and the product are always carbon dioxide and water. So, if someone asks you what is a combustion reaction, that is the burning of hydrocarbon with the use of oxygen, and the product are always carbon dioxide and water. Alright. Okay. Next, combustion is used to heat homes, like in some countries with cold weather. Octane can be used as gasoline, and more examples of hydrocarbons, alright? So, ethane, butane, okay? So, heptane or hexane, they are used as fuel, and with the use of oxygen, you can now have your combustion reaction. Okay, so we have here an example of combustion reaction, and what do we have right here? So we have pentane. Alright, so we have a pentane here. So if I'm correct, that is pentane. Alright, so next one, we have oxygen, we have carbon dioxide, and we have water. Now, is it balanced? So, by just looking at the carbon, it is not balanced. Okay? Now, in order to balance it, okay, just do what we usually does. All right, so we have C. Okay, because we do not have metals here, we prioritize now the non-metals except for oxygen and hydrogen. So oxygen and hydrogen. So we have on the other side oxygen and hydrogen respectively. So how many carbon? We have 5. How many oxygen? So we have 2. And how many hydrogen? We have 12. Okay, so we have so what do we have right here? Carbon, we have 1. Oxygen, we have 2 plus 1. 2 here plus 1 on the other side. So that is 3. Next one, how about the hydrogen? So we have 2. Okay, go. Alright, so I will use different colored pen for this one. Now, let's balance the combustion reaction that we have right here. Now, if carbon has 5 over here, Right? If carbon has 5 over here, so let's try putting some 5 here. Alright, there you go. So make it 5 times 1, that is 5 carbon. Okay, so we have 5 carbon. Then it will affect the number of oxygen on the other side. So we have, so 10 plus 1, 5 times 2, 10 plus 1 is 11. Alright, so that will be impossible. Alright, so that is impossible, guys. So 11. So we cannot have this one. So let's say it that way. So let's take a look at the hydrogen. So if we put if we put a multiple of 2 here that has an answer of 12, all right? So let's have 6 example. Okay, so we have there 6 times 2, that is 18. 12 rather. 6 times 2. Okay, so that will be 18. Sorry, 12. I'm answering 18. Alright, so 6 times 2, 12, then that is balanced. Now, let's take a look at the effect of on the hydrogen. 6. Alright, 5 times 2, 10, plus 6, 16. Alright, so let's think of a number. Let's think of a coefficient that when you multiply by 2, the answer will be 16. So that's none other than 8. Alright, so 8 times 2 is 16. So therefore, 5 there is balanced, 16 there is balanced, and 12 there is also balanced. Alright, so that is one example of combustion reaction. Alright, so let's take a look if we got the correct answer. Alright, so there you have it. Alright, so let's try the one at the bottom. So let's erase the writings that we did earlier. Okay. Erase. There you go. Okay, so this is okay, so this is so it has a big value over here. Alright, so how to predict products in combustion reaction. Okay, so if you have a combustion reaction, automatically the product will be CO2 and hydrogen. Right? So there's no contest about that one. All right, so let's write down. Let's write down our balance. So we have carbon, oxygen, and oxygen and hydrogen. There you go. Then carbon, oxygen, and hydrogen. Now, in this case, we have 10, and we have 2, and we have 22. Okay, next one. We have 1, then we have 2 plus 1, that is 3, and we have 2. Okay, so the problem here is this one is so big. Alright, it has a big numbers, and this one has some small numbers. Alright, so let's use different colored pen for this one. Okay, so how do we analyze this one? Okay, now if you put 10 here, what will be its effect? Okay, let's put some 10 here. So times 1, so it will balance the carbon. But let's see if the oxygen will balance. Alright, so let me erase this one so that we will not be confused. Right. Okay, so we have 2 plus 1. Okay. So let's use the blue once again. Okay, so 10 times 2, that is 20. That is 21. 10 times 2 plus 1 is 21. Now, alright. Now, let's see if the hydrogen will do good for this one. Okay, so 22. Let's think of a multiple, alright, of 2 that has the answer of 22. So that will be, alright, so that will be 11. 11 times 2, that is 22. Alright, so that will be 22. Now, the effect on oxygen will have, alright, 11. Okay, let's see. 20 plus 11, that is 31. Alright? That is 31. Now, our problem is there is no such answer. You cannot have a fraction on this. Alright, you cannot have a fraction on this. Okay? So, what we will going to do? So, let's repeat again the process. So, by erasing all the numbers that we have. Alright, so which means that attempt is not possible. There you go. Okay, let's do it one more time. Okay, so let's think of a number that can be used here. Alright, that can be used here, which can be possible answer for this one. Okay, let's use 2. Okay, so 2 times 10, that will be 20. Right, so that will be 20. Next one, so we put 20 here. Right, so we'll put 20 here. So 20 times 2, that is, alright, 40. Sorry, 20. Alright, so that is 20. There you go. So 20 times 2, that is 40 plus 1, 41. Alright, so what do we have on the hydrogen? Okay, what do we have on the hydrogen here? So we have, okay, so on the hydrogen, so we have 22. Okay, so 22 and that is 11. So if that is 11 still, sorry, the hydrogen here has 22. 22 times 4. Alright. Let me get my calculator. Alright, so 22. Alright, so 22 times 2. That is 44. Right, so 44 on this side. Now, we should think of a number that can be multiplied here to answer, to get 44. Alright, so we can have 22 as well. Okay, so we can have 22. So we can have 22. 2 times 22, that is also 44. So far, these two are working good. They are balanced. Now, it will have an effect on the oxygen. So we have, okay, so we have 22. Alright, so 40 plus 22, that is 62. Alright, so let's think of a number, then when you divide it by 2, alright, so when you multiply it by 2, the answer is 62. Alright. That will be 31. There you go. Okay, let's see if it is balanced. So 31 times 2. Right, 31 times 2, that is 62. Okay, so this is 62. Next one. So 2 times 20, that is 40. Plus 22. Alright, so plus 22, that is, alright, 62 as well. So this is balanced, balanced, and also balanced. Alright, so that is your combustion reaction. We got a big number here. Alright guys, so we got a big number here. So 2, 31, 20, 22. Okay, so this is the normal numbers when you balance a chemical reaction like combustion reaction. Alright, so with that, alright, so that ends up our video lesson that discussing all the 5 types of chemical reaction down to synthesis, decomposition, single replacement, double replacement, and combustion reaction. So I hope you did learn something from this video that we have. All right, so from this lesson. So if you did learn something from this lesson, just hit the thumbs up on this video. It is located there under the video, and don't forget to subscribe on my channel, and that will help a lot. All right, so and also click also the notification bell for more videos like this in the future, and don't forget to write your comments and suggestion. All right, on the bottom part of this video. All right, on the bottom part of this video, the comment section, it will help me a lot. All right, so that ends up our video lesson, and stay safe guys, and peace out.